Yeah, welcome. Permutation is the arrangement of things with regards to their order. That is, the position in which each element stands matters a lot. The number of ways of arranging n objects in r ways is calculated as n factorial over n minus r factorial as seen in the formula. N are the numbers available or the available values. R are the possibilities of permutation. Then factorial, multiplication of a number down from itself to 1. N factorial therefore will give n multiplied by n minus 1, n minus 2, n minus 3 up to 1. And so let's look at examples to explain factorial. Example 1, 4 factorial. That's multiplication of 4 down to 1. 4 times 3 times 2 times 1, we get 24. 8 factorial will give us 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and then the result 40,320. We can also multiply 2 factorials together as seen in the case of 6 factorial, 3 factorial. We expand 6 from 6 down to 1, multiply by expansion of 3 from 3 down to 1, and the result 4,320. Likewise, we can divide factorials. We can have 9 factorial, for example, divided by 4 factorial. I'm going to expand 9 until I get to 4 factorial, so that the other 4 factorial under can divide one up. And so there we get our result. Now let's move on to examples. Again, 2. You have 12 factorials divided by 8 factorial. And of course, expand 12 factorial until you get to 8 factorial, so that 8 factorial can cancel 8 factorial. Now, examples on permutation. In how many ways can the letters of the word charity be permuted? We see that charity has 7 words. And so in other words, we can arrange that in 7 factorial ways. And that is going to give us 5,040 ways of permuting it. If we are given the word easy, and we have to find the number of ways, we can rearrange the letters. Easy has 4 letters, and that means we can arrange it in 4 factorial ways, and that will give us 24 ways. There are just 3 seats left in the front row of a cinema, and we are to find the number of ways 8 people can sit there. The number of people available 8, the possibilities of sitting down 3. And so we're using the formula of permutation n permutation r. N is 8, r is 3. So it becomes 8 permutation 3, and that will be 8 factorial over 8 minus 3 factorial. Expanding and dividing, the answer we get is going to give us 336 ways. Find how 5 slots can be occupied by 7 people. In order to do that, we know that n will be equal to 7. Available slots will be 5. And so, using the formula we have, that will be n permutation r, giving us n factorial over n minus r factorial. N is 7 factorial over 7 minus 5 factorial, giving us 7 factorial over 2 factorial. When you do that, the answer is going to give you 2,520 ways of to sit down. Now we look at indistinguishable variables in permutation. These are variables that cannot be distinguished from each other. They are variables that we cannot say which of them is which. And so therefore, examples like this, how to arrange the letters of the word mathematics. We can see that mathematics has M, 2 M's, has 2 A's, has 2 T's. Now these letters, if you look at them, they cannot be distinguished from each other. M is M, A is. We can see that mathematics has M, 2 M's, has 2 A's, has 2 T's. Now these letters, if you look at them, they cannot be distinguished from each other. M is M, A is A, T is T. And so we cannot tell which of them is which one. That is indistinguishable. Looking at mathematics, it has 11 letters, and so by the time we want to find the number of ways to permute this, it becomes 11 factorial over the indistinguishable ones factorial. That's 2 factorial for M, 2 factorial for A, 2 factorial for T. And in the end, the answer gives How many ways can the letters of the word execute be arranged? Execute has 7 letters and 3 indistinguishable E's. And so in order to arrange this, we get 7 factorial over 3 factorial for the E's that are indistinguishable. At the end of the day, if we expand this and divide through, as we've done earlier, we'll discover the answer will give us 840 ways. Conditional permutations. This is a way by which we permute given values by a particular condition. Looking at the example before us, we can see we are to permute the word greatly. 1, if the letters are all eligible for it. And so we can see that greatly has 7 letters, and that will mean we can permute it in 7 factorial ways. That gives us 5040. The condition in B is that if the letters E, A, and T must always be together whenever we arrange them. So if that is so, we consider E, A, and T as one block of letter. And so instead of having 7 letters, it means greatly we now have 5 letters. And so that will be arranged in 5 factorial ways. Remember, E, A, T are 3 letters. Those also can be arranged in 3 factorial ways. At the end of the day, we can arrange this word under this condition in 5 factorial ways multiplied by 3 factorial ways. And at the end, we get 720 ways of arranging it under that condition. Now, find the number of ways the letters of the word statistics can be arranged if A and T must always be together. The number of the words in statistics happens to be 10 characters, and of course it has indistinguishable letters in it. We have 3 S, 3 T's, and 2 I's. So going by the condition that we are given, that if A and T must always be together whenever we are rearranging the letters, then we are going to take A and T as a block of letter, one block of letter. And so if that is true, they are counted as just one. And so therefore, recounting, we discover that statistics we now have 9 letters instead of 10. And so that means we can arrange it in 9 factorial ways and divide the result by the indistinguishable 3s, 3t, and 2 i's. So that gives 3 factorial, 3 factorial, 2 factorial. Then at happens to be 2 letters. We multiply them also in 2 factorials. And so the answer at the end of the day gives us 10,080 ways. Moving to the next example, 5 men, 3 women are to occupy the front row in a gathering. If the women must sit together, is one condition. The second condition is if the women must sit separately. Now let's see if the women must sit together. Of course, like the previous one we've done, we are going to consider the women as one entity. Thereby, we are going to have 5 men, and the women making one entity becomes 1, hence giving us 6 people. And so the women that are considered as 1 will be arranged in 3 factorial ways, and of course the entire arrangement therefore becomes 6 factorial multiplied by 3 factorial, and in the end we are going to get 720 times 6. That gives us 4,320 ways. Now if these women must sit separately, that's a very interesting aspect. So it means that the men will be permuted first. 5 factorials, that's the number of ways the men can sit. So leaving the women to sit separately with men in between them. So looking at it, we can see that if the men are sit, then there will be 6 available space for the first woman to occupy. So therefore becomes 5 factorial for men multiplied by 6 spaces. Once that is occupied, we are left with 5 spaces for the second woman and 4 spaces for the third woman. So when we multiply all of these, we are going to get 14,400 ways of arranging this. Now we move on to circular permutation. In circular permutation, it is the arrangement of things around a circular object. And because that has no beginning, we have to pin down one person while others rotate around it. And so the formula is n minus 1 factorial times 1. So in the given example, 8 people are to sit around a table in a meeting. So this is going to be 8 minus 1 factorial times 1. And so that will give us 7 factorial, and we'll get 5040 ways. Now look at the second question. The question says there are 10 members in a board meeting, and in how many ways can they sit if two particular women must sit next to each other? In this case, we can sit the people together by pinning the two women as the start point. So if we pin the two women as the start point, it becomes n minus 2 factorial, and the two women can be arranged in 2 factorials. So therefore we get 8 factorial multiplied by 2 factorial, and the answer there will give us 80,640 ways. Now here is an interesting one. A class of 14 students consists of a set of identical triplets and 2 sets of twins, identical twins. Now, in how many ways can these students be arranged? We know students in the classrooms are being arranged in rows and column. So therefore, looking at this, we have 14 students as the number of n. Then the indistinguishables, we have 3 for triplets, then 2 for the first set of twins, and 2 for the next set of twins. So it becomes 14 factorial divided by 3 factorial, 2 factorial. Thank you for watching. Kindly like and subscribe. See you in the next one. Bye.